Hello guys, today we're going to solve a sample problem in Chapter 11 of Thermodynamics and Heat Transfer, the combined conduction and convection of heat transfer. The sample problem is, consider a 1.2 meter high and 2 meter wide glass window whose thickness is 6 mm and the thermal conductivity is 0.78 watts per meter degrees Celsius. Determine the steady rate of heat transfer through this glass window and the temperature of its inner surface for a day during which the room is maintained at 24 degrees Celsius, while the temperature of the outdoors is 5 degrees Celsius. Take the convection heat transfer coefficients on the inner and outer surfaces of the window to be 10 watts per square meter degrees Celsius and 25 watts per square meter degrees Celsius, and disregard any heat transfer by radiation. The given values are: height is equals to 1.2 meter, the width is equals to 2 meter, and the thickness is equals to 6 millimeter, which is converted into meter, which is equals to 0.006 meter. The thermal conductivity, which is equals to 0.78 watts per meter degrees Celsius, and the heat transfer coefficients, which is 10 watts per square meter degrees Celsius and 25 watts per square meter degrees Celsius. The thermal conductivity of the glass is given to be 0.78 watts per meter degrees Celsius. The area of the window and the individual resistances are: area is equals to 1.2 meter multiplied to 2 meter, which is equals to 2.4 square meter. The thermal resistance of the inner surface in equals to convection thermal resistance is equals to 1 over heat transfer coefficient on the inner surface times the area. Plug in the values. We have 1 over 10 watts per square meter degrees Celsius multiplied to 2.4 square meter, which is equals to 0.04167 degrees Celsius per watts. The thermal resistance of glass is equals to length over thermal conductivity multiplied to area. So plug in the values. We have 0.006 meter over 0.78 watts per meter degrees Celsius multiplied to 2.4 meter square is equals to 0.00321 degrees Celsius over watts. The thermal resistance of the outer surface is equals to convection thermal resistance equals to 1 over heat transfer coefficient on the outer surface times the area. So plug in the values. We have 0.01667 degrees Celsius per watts. The total of thermal resistance is equals to the thermal resistance of inner surface added to thermal resistance of glass and the thermal resistance of outer surface. So plug in the values. We have 0.04167 degrees Celsius per watts plus 0.00321 degrees Celsius per watts plus 0.01667 degrees Celsius per watts, and the total value is 0.06155 degrees Celsius per watts. The steady rate of heat transfer through window glass is then expressed to rate of heat transfer equals to temperature of fluids sufficiently at inner surface minus its outer surface over the total of thermal resistance. So plug in the values. We have 24 minus negative 5 degrees Celsius over 0.06155 degrees Celsius per watts Then crush out the units, we have 471 watts as our rate of heat transfer. The inner surface temperature of the window glass can be determined from inner surface temperature is equal to temperature of fluid sufficiently at inner surface minus the rate of heat transfer multiplied to convection thermal resistance at inner surface. Plug in the values, we have 24 degrees Celsius minus 471 watts multiplied to 0.04167 degrees Celsius or watts. Then crush out the same units, we have 4.4 degrees Celsius as our inner surface temperature. So that's all for today, guys. Thank you for watching.